Swayam Prabha. Digital India. Educated India.
Hello everyone, welcome to NPTEL course on groundwater hydrology and management. This is week 10, lecture 1. In the past weeks, we have been looking at the major concepts of groundwater, and then we looked at specific data that we use to understand the concepts of groundwater. And now we are in a stage where we can collect the groundwater data and use it for our understanding. On that note, this week we'll be focusing on more groundwater data availability, websites, and see how we could use it in our assessments. Since this is a introductory course, we'll be showing how to first use this groundwater data, and then in a downloaded fashion, how you download it and use it. And then we will look at how we can put it into a conceptual model in week 11. So first, let's do a recap of week 9 and how it is linked to week 10, which is this week. The week 9, we looked at a very important data for understanding groundwater aquifers and aquifer distances, how it is placed, the boundaries, etc. We looked at boreholes and bore log data. And that is the deep aquifer kind of drilling, where you drill and then you take a core out. A core is a sample which comes out after drilling and then or while drilling, and then you have layers in the core. That layers were used to stratify, create multiple layers of the aquifer so that we know how water moves between the layers. We looked at WRIS data portal, which is the Indian Water Resource Information System. So it's normally called India WRIS. WRIS standing for Water Resource Information System. Sometimes the website does have some lag or it has some issues while pulling up the maps. So don't worry, just revisit it often a couple of days, you will get the data. The link is correct. What link I'm going to show today is going to be correct. But sometimes you may not have data populating because of the hardware, software maintenance, etc. So this, we looked at WRIS groundwater data for stratification. And then there are more data in the portal that we'll be exploring in week 10. We may not be able to get in depth of each and every data that is stored in this website. However, my duty is to introduce these concepts so that you can slowly build an understanding for these by linking it to the weeks before we had this class. So in week 10, we'll be looking at aquifer 2D properties. Okay, so basically a core was giving you a 3D layering, right? You have at one point, how is it layered differently? And then 2 points you can take for a 3D visualization. But there are some properties which is 2D that we'll be looking at in the aquifer 2D property tab. Then we would slowly look into the most important data, that is the groundwater level data. And then we'll also look at some state data. So there are central groundwater board data and then state groundwater board data, which we'll be looking at. So the fund comes from the central government for water management, water resources. That goes to central groundwater board for monitoring groundwater resources. And then we have the state agencies that monitor the state water bodies. Sometimes there is one district with 2 wells monitoring the same water level, whereas one is for the state, and one is the central groundwater board. So mostly these data should talk to each other, but they are also standalone. I'll go through the examples. Then we'll look at the groundwater resource estimation tab, which talks about how to estimate groundwater resources, the water budgets. We'll look at groundwater resource availability, the current availability, the past availability, and some hydroclimatic data. We may spill this into week 11 because it is a very important chapter. So if there is a week 11, then we will finish off with a conceptual model which requires all this data. And this helps us in mapping this aquifer boundaries, understanding why these boundaries are made. And once the understanding for the boundaries are made, you are able to incorporate it in your water management plans. This year is the UN Water Resources Water Day is given to the groundwater focus, and the theme is making the invincible visible. So whatever you're learning in this course over these weeks is very important for this year, 2022, of which 22nd March is celebrated as the World Water Day. And this specific year is devoted to groundwater. So I'm very proud that all of you are taking this course because you are learning something that is not fully taught in classes. Okay, so this is how the website looks like. I will pull up the website to show you quickly. Okay, we would be looking at the website, which is India WRIS/aquifer, and this is the aquifer properties that will come. You will go into this India Water Resource Information System. Depending on your internet connectivity and the connectivity at the WRIS website, there will be some lags. So please adjust, and let me now show you the India WRIS website, which I'd like to. Okay. So what you see here is the India WRIS website. We're back on there, and we go to water data, go to groundwater data, go right. So I'm not clicking. You just have to move your mouse along this tabs, and it will populate. So go to water tab, don't click, and then come down. Each one will populate. If you're taking the rural water resource management course, you will be looking at these other tabs. But since we are looking at groundwater in this course, let's go into groundwater and then move right. You'll go into the exploration details of lithologs, which we saw in the last week's last class. In this week's class, first class, we will look at aquifer 2D. So I've clicked it. And as I said, depending on your internet speed connectivity, it will take some time. Let it populate. Now it has populated. You can move the mouse to the center and then zoom out to show the whole India page. Now you can see it. Okay. Let's start from the right. The right gives you the manual or what each one is. Okay. It gives step by step homepage module, zoom in, zoom out. As I said, you can zoom in, zoom out using your mouse, the default layers, etc. We'll go through all these in class now. Okay, and you can print, and all these will be updated regularly. What is the base map you want, all these things. So I'm going to move this to the side a little bit. See, if you move this to the side, then there's more space for the other contents to come in. Okay, so that's what I did, and I'm just moving this so that the India map can be big. And you can also keep this to the side if needed. Okay, this is plus is to zoom in, zoom out, and then you could rearrange them back, or if you want the table, you can click that. Okay, so let's start with the base map. If you click the base map, you get what is behind the aquifer mapping. So what this page gives you is the 2D not the depth, the XY plane of the groundwater. What type of aquifers are there and why are they called, how much area, those kind of things. So for that, it is important to understand the base layer, underneath layer, which shows you the different boundaries. Okay, so the base layer can be dark, imagery, etc. If you have slow internet, always use streaks. Do not use these other layers. For example, I'll show you the imagery. It is the real-time image from satellites. Okay, you can see the green color, brown color, etc. So, but that takes a lot of internet speed. So for the best thing, you can use a street map, which is a static map, and you can do that. So again, click on the base map, it will become small. Okay, and then the print user guide, everything is there. You can create a basin-wise map, or you can create this arrow mark and push the legend to the side. Now you can see the whole of India, and or you can do a basin. For example, administrative is your state boundaries or district boundaries. Let me focus on Maharashtra, where IIT Bombay is. Okay, I'm zooming in. So now it is a state boundary. Sooner you will see the district boundaries if needed. I'll have to turn it on. Okay, and then you can select a state if you want to focus on better. For example, let's say Chandigarh, and the whole map will shift to Chandigarh, and this data is also getting populated. Okay, good. So let's do back for full India. Okay, if you want the full of India, you can just zoom out, and if you zoom out, you can see that as this map, the 2D map is getting populated, you will see other data also change. Still, this is Chandigarh. Because of this, you can click the X mark, it will go off, and then this will slowly do to India. Okay, now the legend has come back to India, and if you go to India scale, this legend will stay. Now, yeah, so now what I'm going to do is I'm going to show you the layers, which is very important for aquifer 2D mapping. Okay, the first is the basin boundary. We have looked at what is a basin. The basin is the watershed, etc., etc. And you know that I've taught you in this class that your groundwater need not follow the basin. So this is like an eye which if has a cut, which means it's closed. Okay, if you want to activate that layer, just click the eye, and the basin is going to get activated. Now you can see the boundaries as basins. Okay. So if I close this, now this becomes back to the district or state boundaries. Okay, and these boundaries can be, the basin boundaries can be CWC, which is your Central Water Commission, and different boundaries are there, administrative boundaries, aquifer system boundaries. What I'm going to do is I'm going to click this, turn off the basin. Now you can see the basin is gone. Okay, administrative, I'm going to take it off because no point of having watershed and administrative on an aquifer, but aquifer system we need. So that is where you can see the different colors of the aquifer and how it is getting populated. On this side, if you see, the pie chart is there to show what is the different aquifers present and how much are there. And clearly, as we explained in class, alluvium is high, and then the hard rock aquifers is the most. The hard rocks can be further divided into basalt, gneiss complex, gneisses, granite, etc. So all these would be clubbed together as hard rock aquifers, whereas alluvium is around 30% in India. Okay, the percentage is actually given up. You can see that total percentage is around 30%, 29.71. So I was at 30%. The hard rock is 60%. Okay, so what you could see here is I'm going down, and as you can zoom in, okay, I'm going to zoom into, let's say, Mumbai, Maharashtra region. You can see that the blue is the basalt layer, and then the orange is the laterite layers. So along the Western Ghats, you have a particular aquifer, and then on the other side, you have different aquifers. Here, the numbers are for whole India. You can see it is for whole India. Even if you zoom in, it will not change. Only when you change the boundary at the bottom, pick a state, then it changes. Okay. Good. So what else can you see? You can see boundaries. You can see the aquifer systems. If I close this, the legend goes off. The I, if I close it, I need it, so I am going to take it up. Okay. Then you can see that is one property. So aquifer system. What aquifer it is one property, 2D property. The next one is the aquifer depth. Okay. So how deep is the aquifer? Is it shallow, intermediate, or very deep? This is done for certain states. So you can see that only 4-5 states are being done. So to see it, you can zoom out of India, and depending on your internet, it takes time. Okay, so since IIT's internet is here, it is coming pretty fast. You could see Kerala is done, Tamil Nadu is done, and other regions are done. Okay, but not Maharashtra, etc. So let me go to Tamil Nadu, but yeah, Tamil Nadu is here, and I'm going to zoom in to Tamil Nadu. You could see that along the coast, it is shallow aquifers, unconfined aquifers, but in most of the key districts and along the dry side of the Western Ghats, the rain shadow region of the Western Ghats, it is pretty deep, intermediate to the, so the units are meters below groundwater level. So ground level. So you have the ground and meters below. So you have to go in the red 150 at least meters down. That is really, really big. Okay. And it's not good for an aquifer system. So understand this, that you need to also know the spread of the aquifer on the top, 2D, but also how deep do you have to go for the aquifer. All these are taken from your bore logs, lithologs. I'm going to close this, but you can also see, like, if you can open it, there's different depths that you have. So for example, if I can open this eye and only keep Tamil Nadu, if I want to see Tamil Nadu, I have to close everything else. Okay. And slowly the internet is also going to show you only this. Good. So I'm going to close this, and then the arrow mark you see, you can move up or down. Okay. If you close it, then you have more space to put these data. Then come down to the aquifer thickness. So depth is depth to the aquifer, but how thick is the aquifer? Okay, the first water is aquifer depth, but then how thick is it? It could be very shallow, like maybe 5 meters below the ground. But if it is not thick, then the volume is not there. Remember, volume is a 3-dimensional. Okay, so I'm going to see what are the different states they have done. And let's focus on Tamil Nadu because we've already looked at Tamil Nadu for one study. So if you click it, you can see this arrow, a small line moving on the top. That is the processing and the internet that is taking time. Okay, good. So now I've done for Tamil Nadu. What you could see is the aquifer thickness is very thin in most parts of Tamil Nadu. That is why there is a lot of groundwater exploitation. Since the thickness is low, a lot of pumps are put and water is taken out. If the thickness is good, then some wells is enough. One farm can have one well and it could suffice. But since it is not enough, a lot of people are putting more and more wells to take the water out. Okay. So the thickness is given by less than 20 meters below the ground, 20 to 65, 65 to 20, and 120. If it is 120, think about it. It's a big aquifer, okay, and water can be stored thickness. So you're coming down, which is fine. I'm just going to draw it for you. Okay, see, if this is your ground level and you're coming down, which is your depth to the aquifer, and then how thick is the aquifer. If it is very thin, then even though you are very shallow, easily accessing the water, you cannot extract more because the water is only this much, okay, thin. But in Tamil Nadu, you could see this is where there is more water, okay. So all this would have a lot of water. And mostly it is because it is alluvial, whereas water is being transported by the streams and then the sediments are deposited as alluvial, okay. Okay, good. So moving on. Moving on. Now let's look at the differences. Why the differences can happen. See, this is not a property that would change because of use. The previous one, aquifer depth, the depth to go to the aquifer can change if you take too much water out. If you take too much water out, then what happens? You have water depletion. And so your thickness is reduced. I'm sorry, the depth reduces, right? Here, the thickness of the aquifer, which can store water, is a stationary property. There is some disturbances you can do, compaction, drilling, and all those things. But mostly the aquifer thickness is there. It is a natural material. If water is there or not is the second question. Okay, so thickness is there. So what it shows here is this is very thin. The groundwater potential is not much. Even if you put wells, even water comes, it won't be enough because it is thin. It is a small bank account. However, these have really good amount of water. And that is because it has a very thick aquifer. Even though you have to go deep, you can get more water out because the aquifer is deep and thick. So you can justify putting money into accessing this water. Okay. So I'll close this aquifer thickness also. There's one more property we need to look, aquifer material. Okay. And there is aquifer material. I'm going to click it on and it is populating. You could see that there is different materials for the aquifer. Let me see if I can pull this down to. Okay, here it is, the legend. So the star marks will give you the legend. What you see here is the aquifer material, which is the not the top material. The top is where we saw granite, the 2D surface, and here is the old name for the geology name for the aquifer. How much, what material was it formed? And that actually disintegrates or weathers down into the aquifer type. Okay, so you have aquifer material and then aquifer type. The aquifer material here, for example, is in this region, you have crystalline rocks. Now the crystalline rocks would weather, break down, and then become hard rock aquifers. So if I turn on the aquifer system, see, I'm going to turn it on. And what is happening here? This is basalt. So basalt is the aquifer system, whereas the type of rock present in the aquifer is your aquifer material. Okay. So that is the difference between aquifer systems and aquifer materials. It might be slightly confusing to understand that basalt is also a material, right? It is a rock. However, the rock came from a geologic setting, and that geology setting is the aquifer material. So you have an aquifer material. It is the parent material. It starts to weather, it starts to break down, and then another material is formed. Okay, so this is called the parent material. And then the other material, which is the recent material, is where water stores. Let me draw a quick diagram for you. For example, you have, yeah. So this is your ground and this is the parent material. Okay, so here, for example, crystalline rocks. The crystalline rocks would be weathering to form a aquifer type, and that aquifer type is basalt in this region. Basalt and laterites we saw for Tamil Nadu. So I hope I'm clear. This is aquifer material as older material, very, very deep, very deep, like geology. And then these are your aquifer types. Okay, so today we have seen the aquifer material, okay, and type of aquifer materials are these. Okay, so you have seen 1, 2, 3, 4, 5. Only for some states they have given it, not for all states. So if I zoom out to the whole of India, you could see that not all states actually it is trying to get it, but it's not there. Okay, the internet also has a lot of data. Yeah. Okay. So with this, I think I've covered the aquifer 2D data that is available. You could download this data as a chart. As I said, when you download it, for example, this data I need. Okay, let me first turn this on so that we can have some data here. Okay, So if things don't switch on, sometimes just refresh it, it will come up. Okay, now I'm going to push this to the side, and I want to show you that this is the data I want to take. The principal aquifer systems in India. If you want only one state, as I told you, go to unit-wise selection, click it, select the state you want, and then take it. Let's say I'm going to do Tamil Nadu. Okay, slowly give it time, and it has come up. Okay, so Tamil Nadu, and click this button to go down. Okay, so Tamil Nadu has been selected. You see the pink line, and this has been also updated. So alluvium is, you have a thickness, you have other data. See, for all India, these data didn't come. Why? Because all India, these explorations have not been done. Only for some states it has been done. And this is where you have the physical properties. Specific yield we've covered, yield, transmissivity we covered, fracture encountered. So some advanced things are there. Thickness we did, aquifer type we did, aquifer system we did, all these we've done. Okay, so the legend is given. So for the coloring, let me close this. See, you can see the coloring, and that is given the legend here. And the shape is given, the pie chart. You can download this pie chart as a PG and CSV. CSV, you don't get a chart, but you get columns so that you can make different graphs, okay, or input it into the model that we're going to show in the next class. And you can download this. It'll ask, are you any of these? Just give, for example, most of you are students. You can put student, put your name, let's say Penan, my name, put your email, and then submit. It will download. Okay, good. So you don't have to have an account, but be careful what details you give, as in you're a student and other things. They want to know how many students are using it, right? So that's why be correctly giving your details. Give your details correctly. And you have any other questions, you can go down here to the manual and look at how to download the data. What is aquifer depth, what is aquifer material. So I'm not reproducing these into my slides because all the data is given here. All the writing is given here. You can also download all of this as a manual by clicking here. You can click, it will open as a PDF like a book. You can use the book. It's free, open source. See, it is in PDF book. Okay, good. I think we have covered the Aquifer 2D tab. The others are user guide, print. You can also print the page, what page you want. I would recommend you to download it and then print it from your system rather than printing a page like this, because then you'll have control of what you want to show, not all the details. Okay, so with this, I would like to conclude today's lecture where we looked at WRIS data for Aquifer 2D properties. Especially the XY properties on the surface aquifer type, and then also the aquifer depth, material. How do you zoom into a particular state? If you look in here, you can also zoom in more. As and when you zoom in, the names also will come. Okay, the names of the special materials or aquifer type, whatever you've chosen. Okay, and some background information of your districts: Coimbatore, Neyveli, Viluppuram, Muthupet, Karaikal, Pondicherry, Chennai. All these names will come, Tiruvannamalai, etc. So how do you want to export it as a layout or as a map? And do you want to export as an image? All these has been given in the export tab or print tab. Okay. You can also put an address here to choose a location. For example, you can put IIT if it searches. Yes, it does. IIT Powai. Okay. So it will go to where I'm taking this lecture now. Okay. And it zooms in too much. So you have to zoom out a little bit to see where it is. And you can see here, it is Mumbai, Maharashtra. Be very careful. It is a very sensitive. So slowly move it. See, if you move one, the other things will move. And then now you can see that, okay, this is IIT Bombay. It has this type of rock. So anyone who's going to ask you these details, you can quickly go to this website and give them the details about this aquifer and our properties. With this, I would like to stop today's class. I will meet you in the next class. Thank you.